Hello and welcome to yet another video of Cornerstones of Math. About a month ago, I uploaded this video where I calculated three areas related to the graph of y equals e to the minus x using series and integration. In this video, I'm gonna do the similar thing again but with the graph of different function. Here we have a graph of y equals 1 over x squared. Then we have these intervals having unit length. Then we construct these rectangles having width of 1 and heights given by the values of functions at x equals 1, 2, 3, 4 and so on. Then we have these line segments connecting the points on the graph. Area A is defined as the area between the graph and the x-axis, starting from x equals 1 and all the way to infinity. Area B is defined as the sum of areas of these infinitely many triangles at the top. And area C is defined as the sum of areas of these small regions between the graph and the inclined line segments. Let us calculate the areas A, B, and C. Here, since the graph of y equals 1 over x squared is involved, we might want to use the famous result of the Basel problem. The sum of the reciprocals of squares of natural numbers is equal to pi squared over 6. First, area A, the area between the graph and the x-axis at x greater than 1. This area is simply given as an integral from 1 to infinity 1 over x squared dx. This is an improper integral because it has infinity right here. This type of integral can be calculated by the limit of integral 1 to c 1 over x squared dx, where we send this c to infinity. So we have limit, and the integral of 1 over x squared is minus 1 over x. So we have limit of 1 minus 1 over c, which gives 1. Next, area B, the combined areas of triangles. Here, let us consider just one triangle located at the generalized interval between n and n plus 1. Let us call this area Bn. Then the base length of the triangle is 1, and since this length is 1 over n squared, and this length is 1 over n plus 1 squared, so the height of the triangle is 1 over n squared minus 1 over n plus 1 squared. So Bn equals 1/2 times 1 times 1 over n squared minus 1 over n plus 1 squared, which simply equals 1/2 times 1 over n squared minus 1 over n plus 1 squared. Therefore, the area B of the infinitely many triangles is equal to the sum of areas Bn, where n goes from 1 to infinity. So we have 1/2 times sigma 1 over n squared minus 1 over n plus 1 squared. Here, the sum of this series is equal to the limit of the partial sum k from 1 to n 1 over k squared minus 1 over k plus 1 squared, and then n goes to infinity. Here, if we write down the sigma part, we have this, and you can easily notice that the middle terms cancel out, so we have 1/2 times limit of 1 minus 1 over n plus 1 squared, which just gives 1/2. Finally, area C that is wedged between regions for areas A and B. The most efficient method is the subtraction method, where we first calculate the areas of all of these rectangles, then we simply subtract previously obtained areas A and B. As for a single rectangle in the interval from n to n plus 1, the width is 1 and the height is 1 over n squared, so we have C equals sigma 1 over n squared, n from 1 to infinity, minus area A is given as 1 and area B is given as 1/2. And now it's time to use the given values for the sum of reciprocals of squares. then we obtain pi squared over 6 minus 3 over 2, or we can write pi squared minus 9 over 6. And that's all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.